simple example. So, on the ledge now. In order, the other one didn't officially stop working. It's right there.
This one?
Yep. Try it, it'll work. So again, we're going to be adding and subtracting today, different fractions. So we're going to start. Let's start with a very basic example. If I asked you, focus people, come on. If I asked you what was 2/3 plus 1/6. Okay? 2/3 plus 1/6.
Yeah, the bottom number has to be the same, right?
Now,
What across?
I'm hearing mistakes, I'm hearing correct things. The bottom number needs to be
The same.
the same. So Enrique's right to start. Remember, with multiplication, you just multiply across. That's the easier one. Adding is actually more difficult. Okay? What is going on, Anissa? Go do what you gotta do. I don't think so.
I'll be back.
All right. Let's all relax and let's start over because we're a little too giggly today. Now, we see right away that we're missing the same denominator, right? And most of you would say multiply by what? Good. You would multiply by 2/2 so that you would get a 6 down here, correct? Yes. Now, here's what I want you to start thinking about. And this is going to sound really weird, but it will help you on today's lesson. Before you figure out what to multiply by, rewrite the fractions with the denominator factored. So, this one is still 2/3 because 3 cannot break up. But what does 6 break up into? 2 and 3. So, what this tells you, I know it sounds weird, what this tells you is that, see how you have a 3 in both denominators?
Yeah.
What's missing in this denominator? The 2. That's where the 2 comes from.
It goes on the
So everybody in the beginning, you all said put a 2/2, and that's correct, and I agree with you. But I'm trying to show you where it comes from actually. The amount of, or the factors in one denominator must be the same as the factors in the other. So if you can factor it, you can just see what's missing and put that on the outside. It's a much easier way to add and subtract fractions. Okay, this is where common denominator really comes from. So here in the end, you end up getting, you get 4/6 plus 1/6, which is, again, simply 5/6. And that's correct. Whether you did it the original way or not, it's the same. But if we have variables, it's going to be a lot harder. And by using this idea of factors, having the same factors in the denominator, it will make it much easier for variables. Okay, so again, I understand that this is different. And I understand that it's new, and maybe it's a new way to look at it. But it's going to help you in a minute. Anna.
So what was the point of doing 2 times 3 in the other denominator?
Breaking this one up in this denominator tells us that we have a 2 and a 3 in the denominator. This denominator only has a 3 though, so it must be missing a 2. That's what tells me what to multiply by. Okay? You look and see what's missing. If it's missing here, if it's missing here, you have to put it in the top and the bottom there. Okay? Rosie?
Well, I was done.
Okay. Let's try one more like this before we get to the actual lesson today. If we have 3/8, let's say minus in this case, minus 12 over, oops, no, not 12 over, let's make it easier. Let's do 7/12 actually.
Oh, that's not easy. Man, my wrist was there.
Now, what was my suggestion to you a minute ago?
Just switch out the 12 and put in
Factors of 12. Very good. So break it down into its basic factors. What can you break up 8 into?
4 and 2.
4 and 2. What can you break up 12 into?
4 and 3.
Okay. Isn't there a 4 in both already? So we're good on the 4s. God bless you. Tissues over there if you need them. 4s are in both, so we're good to go with the 4s. Either way, this way, come on. Over here, what am I missing that's over here?
3.
A 3. Be careful there. Oh,
You're telling me go over there.
because you always leave it open every time you come back in. You just did it again.
It
happens every time, huh?
Just in case
Now-
something.
Again, no, it is there. here we have a 4 and a 2, enough. Here we have a 4 and a 3.
Right.
So there's a 4 in both cases, but I'm missing a 3 over here. So I multiply by 3 over 3. So now my denominator has a 3 and a 4, just like this one has a 3 and a 4. But now what is this one missing? A 2. This is how you really get a common denominator. And what do you notice? Your common denominator turns out to be 24, which makes sense, because 8 goes into 24, and so does 12, your original denominators. Okay? So whenever you do these problems, try and break up your denominator into factors that are in both, and then see what's missing. Okay, so if you want to write the continuation here, the numerator is going to become a 9 over 24 minus 14 over 24. Now my denominators are finally the same, so I can just subtract the numerators. 9 minus 14? Negative 5 over 24. And again, remember, please, the denominator doesn't change that. Once you get a common denominator, you just repeat it. I have an then on.
Can we just put in, like, do we have to do that, can we just put in, like, and make it?
The negative can just go out in front like this,
Yeah.
or the negative could technically go like this, believe it or not. You could put it down below also. Any of those are acceptable. Because if there's one negative, it means the whole thing is negative. If there's two negatives, it's positive. Because you can't see. On?
Oh, so would it make a difference if, you just answer right there.
Mr. Howard, this is the common denominator.
This, what we're doing now, we're finding the least common denominator. Correct. I'm going to go through all the steps with variables. Guys, this is like 6th and 7th grade math here, if you remember. Okay, it really is. It might even be below that. It could be like 3rd and 4th grade math with fractions. You added and subtracted fractions when you were very young, so you got to think far back. Now, today, before you take a look at all these notes here, before this, these are the kind of problems we're going to be doing today with all these variables. And we need the same steps, believe it or not. Exact same steps. So, to write down your steps first, I'm going to give you a minute. Okay? Spend some time writing these steps down. If you think you don't need steps, you don't have to write them down. Abbreviate if you would like to. So again, we're on concept 40, adding and subtracting rational expressions. Who can tell me again, what's a rational expression really mean? What do we really?
A number that's able to be, like, it's not decimal, it's like a clear number, right?
Okay, good. It could be a decimal though. It could be real.
We divide it on, yeah, right.
What is a rational expression again? What did we just add together? What are those called? Fractions, right? A rational expression is just a fraction. So we're adding and subtracting fractions, but we call them rational expressions because there's a lot of variables in them now. Okay? Again, we're really just adding and subtracting fractions. That's all we're doing. The rule, as always, whether it's variables or numbers, to combine fractions by the operation of addition, you must have the same denominator. And remember, subtraction and addition are really the same thing. You're just adding the opposite. The first step is to factor the denominators completely, just like we did. We factored 8 into 2 and 4. We factored 12 into 4 and 3. The second step is to find the least common denominator of each fraction. Okay, by multiplying the numerator and denominator of each term by what is missing in the denominator. And leave your denominator in factored form. What step are you on writing? Sue, I heard 5?
5.
She started writing right away. Maybe you have to write a little bit. There it is. Guys, use shorthand. Don't write the word and. You don't have to write, for example, denominator, write DEN, dot. A lot of these things, multiply, MULT. Shorthand, please. Number 3, add or subtract the numerators and carry over the denominator like we did with the 24. The last 2 steps are the tough parts because at the end you could possibly factor the numerator and simplify even further. And we're going to see how to do that in our second example today. We have 2 examples to do. Today. We're going to do 1 adding and 1 subtracting. Your homework tonight is 6 examples. In addition to those 6 examples, I have another worksheet for practice for you with another 8 examples. So this weekend, I want you to really do 14 examples, okay? It's a lot of practice, but I'm telling you now, the more you do this, the quicker it is. If you are completely sound, and by sound I mean confident in your work, with this topic, you should be able to do the homework in like 15 minutes. If you're having trouble, it might take you like 30, 45 minutes. But you have tonight, you have tomorrow night, you have Saturday all day, you have Sunday all day. Again, I know you have other responsibilities, but try to make time for this stuff. Let's go on to the next one. I know some people aren't done. You gotta wait a little faster. First example. Based on the last thing we just did with the numbers, think about the denominator again. So start by factoring your denominators. So I'm going to leave the numerators alone for now. Leave your numerators alone and tell me what you can factor. Over here on the right side, take a look at this one I'm about to box in. What's your GCF again? X and 3. 3 and X are in both. So take out a 3X. Now, if you want to remember what's left, you remember, divide by the GCF in your mind. What's 3X divided by 3X? 1. 3X over 3, the 3 and the 3 cancel. X squared and the X cancel. What am I left with?
X.
And I carry down the plus sign. Again, many people got this wrong in the other class. You have to remember to carry down the 1 from the 3X over the 3X. Now, here's what I want you to notice next. Over here, 9X squared. What can I really split that into? 3X and
3X?
And 3X. Not just 3, don't forget. You could write it as 3 times 9, you could write it as 3 times 3X squared, but that doesn't help me because now there's not common. So write it as, instead, 3X times 3X, because now you see you have a 3X in both denominators. Look at your denominators, please. Notice one of them already appears in both. So that's common. We're good with that one. So put like a check mark next to it if you want. But on the left fraction, I don't have an X plus 1 over here. Again, over here on the left, I'm missing X plus 1. I see it on the right. So what do I multiply by?
1.
Be careful.
That's what I said.
X plus 1. Again, because I'm missing it on the left side. I've got an X plus 1 on the right side, but I happen to be missing it on the left side. Now, here's what I recommend you do. Take a look. Put parentheses around anything you're multiplying by. It will help you in the end. And next problem, you'll see why. Sometimes if you have a binomial up here, so if you had like X plus 2 over here, you would have to FOIL that out. So that's why we're putting the parentheses there. Now, in this denominator, I've got X plus 1, I've got 3X, and I've got another 3X. So what's missing over here? Another 3X. So multiply by 3X over 3X. And now look at your denominators. What do you notice? They're the same. So carry them down, please. So on the next line, write one line with the same denominator. Okay, there's my denominator, and I'm leaving it in factor form. And you'll see why in a minute. Leave it in factor form. It's the same denominator. In the numerator, I've got a 7 times X plus 1 from over here. And I've got X times 3X. X, so plus X times 3X. Okay? Again, this is where I'm at right now. Does everybody understand what I'm doing? So the denominator, did I do anything to it really? Once they were common, I didn't do anything. But the numerator, I combined. I saw that this was 7 times the quantity X plus 1 plus X times 3X. Now, in the numerator, can I go ahead and simplify a little? Numerator, what can I make this? 7X plus?
1. 7X plus?
Not simplifying though. I'm trying to go a little further.
7.
Plus 7. Plus, what is X times 3X?
3X squared.
Now it looks like I have a quadratic up top.
But in the end,
Well, that's no buts yet. So again, I was up there. I distributed the 7. I got to the next line there. Look at your numerator. If you have any like terms at this point, you should combine them. In this problem, excuse me, there happen to have no like terms, right? You see how there's no like terms there?
Yeah.
We've got a 7x, we've got another x there, and we've got a 3x squared. So there's no like terms, but I can put them in order. I can put them in order, write it as 3x squared plus 7x plus 7 all over this. Now, what did the last two steps say in our notes a minute ago?
That's,
Factor the numerator and simplify. Because look, the numerator is a quadratic now. So I might be able to factor it, and if one of my factors turns out to be x plus 1, I can cancel with this. Everybody see that? Again, I might be able to factor this numerator. If I can, and one of the factors happens to be x plus 1, it will cancel with the denominator's x plus 1. So my goal now is to find out if I can factor this. What method must I use? AC. Again, because of the fact that this 3 is here. So if I want to factor this, AC is equal to 21, and B is equal to 7. Again, AC is taking A times C, those two numbers there that are underlined. B is the middle value. Are there any numbers that multiply to 21 and add up to 7? What multiplies to 21? 3 and 7 only, right? Again, to get to 21 here, you can have always 21 and 1 or 7 and 3. Those are my options that multiply to this. Do either of those options add up to 7?
nah,
Neither of them do. Do any of them subtract to give you 7?
nope.
No. Again, this would either give you 10 if you added them,
Is it
or
a
4. This would give you either 22 or 20. Neither of those are 7. So you can't factor this. So the roots of this one must either be imaginary or irrational. So for this problem, this is your final answer, it turns out. You can't go any further because AC method failed. Again, you can't factor this because AC method showed us that there was nothing to factor. Could I have taken a GCF out in the beginning of the numerator alone? Because 3 and 7 are not multiples, right? And x is not in every term. So I can't take out a 3 or an x. When this in the beginning has another number. Here's the answer. Write it down. Right now. AC method is used when A is not equal to 1. Bridget.
How come when you had 7 times 2c,
X plus 1. How come I distributed it?
how come you couldn't cancel that one?
Oh, take a look. Here's Bridget's question, people. Look at the top line here. See this x plus 1 here and this x plus 1? Why can't I cancel them?
Because one's an added.
Because this plus sign makes this whole thing an addend now. If this was a time sign, Bridget, and they were all time signs, they would all be factors. X plus 1 and 7 are factors of each other, but of the whole top, x plus 1 turns out to actually be an addend because it's being added. You need all multiplication signs to cancel that. Okay? How come a little louder? How come there's only 2 of them? Because look at the original. You had x plus 1, 3x, 3x. X plus 1, 3x, 3x. You just carry one of them down. So you just carry like this denominator down to here, or this denominator. They're the same denominator. Remember? Guys, whenever you're in doubt, here's what I want you to think. 1/3 plus 1/3, isn't that just 2/3? Did you change the denominator?
No.
So you don't change the denominator there either. Okay? One more problem. Again, we're doing only 2 problems today, guys. 2 problems. Take a look at this problem. You can always start by factoring, but notice right away, what is the operation that is being asked to do?
Subtraction.
Which is really defined as?
Adding the opposite.
Good, adding the opposite. So, leave the left part alone, please. Leave that alone. I'm going to write this now. If I want to add the opposite, what does that mean, really?
Make them run negative, switch them both sides.
Good. So I make this a positive one, then what signs do I have to switch?
All of them.
What's all of them? Give me an example.
Like 2x
Becomes?
plus 1,
Okay?
and then negative x.
Okay, you made the common mistake there, and I wanted to explain why. I feel bad that I kind of goaded you there, but you did make the
Goaded
common
me?
mistake. Kind of led you in that direction. The denominator doesn't change. That's the trick here. Because look, if you're adding the negative value, you're really adding the negative 1 up top. Let me explain. If I had negative 2x plus 1, and that's coming off of x squared, or let's say it's coming off of, say, 5x. So this is a side note. Just write this on the side, please. If I had this problem here, and I was saying that's a minus, wouldn't I really just distribute the negative 2 to both? And this becomes 5x minus 2x minus 2. Again, take a look here. This negative 2, I could really just distribute it to each of these, and that's what I get. And then I can combine like terms. 3x minus 2 it becomes. So when you have a negative, you distribute it, don't you? So this is really, now go back up here. This is really like having a negative 1. So you need to distribute the negative 1. But when you distribute something, you only distribute to the top. You don't distribute to the bottom also. Again. So when you're doing this problem, when you rewrite this line, so again, this line doesn't really matter here. When you're doing this problem here, all you're going to do is change the numerator sign, not the denominator. Everybody clear on that? Make that a plus. Make that a 2x plus 1 over x squared minus 4x plus 3. Again, think about it this way. If you changed all the tops and you changed all the bottoms, it would be multiplying the top by negative 1 and multiplying the bottom by negative 1. But if you multiply the top and the bottom both by negative 1, what happens to those negative 1s? They turn positive, because two negatives make a positive. So really, if you were to switch all these bottom signs, it would be like putting a negative 1 down below also. And then these negative 1s would cancel, which would make that just a positive, which doesn't really do anything to my problem. Okay, so remember, for this kind of a problem, you are really only affecting the numerator. The numerator is all that matters.
All the numerators or just that?
What do you mean by all?
Because like
Oh, no. Just that one, because again, Rosie, we are subtracting, the whole goal is that we're subtracting this entire quantity. So we only need to change its signs. We don't need to change the signs on the left. Please write this down, people, because everybody makes this mistake on the SAT exam here, okay? When you have to subtract something, you're really only negating the numerator, not the denominator. And take a look, if you negated the denominator, that would be very tough to factor also. Notice that right away. You would have all negative signs there. Now, let's continue the process. So we didn't even get to step 1 yet. That was the preliminary step, where when we had subtraction, we switch all the numerators.
So it's preseason.
Preseason. Now let's get into regular season, and then at the end we'll get to postseason. Denominator, factors. Again, the whole goal is to leave the numerators alone right now, and only factor the denominators. What do we got here for the denominators? Who can tell me?
Denominator.
What can I factor out of the 2x minus 2?
2.
A 2. What does it leave behind?
X, right, is, no, it's X.
Divide both of these by 2 in your mind.
A negative 1.
Everybody see how easy it is when you listen to what I tell you here? Divide by the GCF in your mind. It makes this a lot easier for you. If you're forgetting this. If you can do it in your head, do it in your head. Okay? But whenever you forget, divide by the GCF, please.
So now we're just doing the denominator.
Again, with adding and subtracting, when adding and subtracting, we need a common denominator. So that's all we care about in the beginning. Over here, what does this factor into? What are the factors of 3?
Oh, 3 and 4. 3 and 1.
3 and 1. And to get a negative sign here,
Both negatives.
they got to both be negative. Very good. Because again, multiplying two negative numbers like these two is what gives you that positive right there. Okay? So now, what do you notice is in both denominators?
That 2 thing. I mean, that x minus 1.
The x minus 1. And there's a good chance that that happens. So, you have to now ask yourself, what's missing? What's missing? What is it? X minus 3 is missing over here. Very good. Please put parentheses around it, as I instructed you last time, and you can see that now. You're going to have to FOIL the numerator on the left side. Okay, you're going to have to FOIL. So if you want to go ahead, put parentheses around here too, you can, to remind you. Again, putting parentheses up here with the x plus 2 might help you remember that you have to FOIL this. Next, what's missing on the right one? What is it? 2. Again, my denominator over here, take a look at it please, consists of now x minus 3 x minus 1, and 2. So I've got x minus 3, I've got x minus 1, I need the 2. Do I have to change my denominators now? I just write them together as one denominator. Now, in the numerator though, we got a lot of work to do. A lot of work. We're going to have, this is x minus 3, x plus 2, we got that, we got to multiply out, and then we have to add 2x plus 1 times 2. Notice what I'm using. What am I using around everything? Parentheses or brackets, either word is fine. Okay, notice what I'm using here. Okay, the parentheses are very important. If you forget the parentheses around the 2x plus 1, you would forget that you have to really distribute the 2 to both of those. If you forget the parentheses over here, you might forget that you have to do FOIL. First outer, inner, last. You got a FOIL there, or box method. Let's go ahead and show that on the next line now. The denominator, leave alone, and you're going to see why we do that at the end. I know it's a long process, guys, but this is what you have to undergo. Here, when you FOIL this, you get x squared, outer gives you 2x, inner gives you negative 3x, last gives you negative 6. Distributing the 2, you get 4x plus 2. In case you're wondering where these came from, this box results in this right here. This circle results in this right here. Okay? Again, remember guys, this 2 out here is a multiplier. If you want to put parentheses around it, that's fine. That's not squared. Don't confuse that. Okay, it's not squared. So at this point in time, the last or second to last step says to combine your numerators, or sorry, the third to last step is to simplify your numerator and factor. Look at your numerator. What does your numerator simplify into? Like terms. 2x, negative 3x, and 4x.
Plus x minus 6. X squared minus x minus 6.
X squared plus 3x.
Very good, Ebony. And the negative 6 and the positive 2? So, take a look. 2x and 4x really gives you 6x, doesn't it?
Yeah.
And 6x minus 3x gives you the 3x there. Negative 6 and 2 gives you negative 4. Now it's actually really cool because look, your numerator, you can factor it. And what you're going to notice is that it turns out to be canceling with one of your denominators. What numbers multiply to negative 4?
1 and 3. 4 and 1.
1 and 4.
4 and 1 and 2 and 2, right?
Negative 4. No,
Out of 4 and 1 and 2 and 2,
Negative 1.
which of those gives you 3?
4 and 1.
The 4 and 1, because 2 and 2 gives you 0 or 4. Now which one needs to be positive?
4 and negative
The
1.
4 needs to be positive because we want a positive 3. So x plus 4, x minus 1, all over still the same denominator, which we have not changed still. And now you notice what happens? The x minus 1 cancels. Okay? And there's your final answer. You can distribute the 2. Notice, people. You can distribute this 2 and rewrite your final answer as this, if you want to. And I want you to remember this. Why? Who remembers why? Ebony is listening for sure. Very good. Thank you. On the SAT, your answer choice may not appear in factored form. It may appear in distributed form. So either of these answers works at the bottom in black here. Again, people, it's 11 o'clock already. We did 2 problems after the homework. So think about this, please. The notes are online. If you are still having trouble, there are 2 readings to do. And when I put readings on here, it just means web pages with example problems. I highly recommend you read through those example problems. And I also put 3 videos up today. And if you had trouble on Concept 39, there's 2 videos and 2 readings. Please utilize Edline. Look under notes. I'm sorry, not under notes. Look under news. Look under news on Edline, and you're going to see all the extra videos I post. So please go ahead and do that. This weekend, you have 2 assignments. Again, one of them is 6 questions homework. Another one is an 8-question homework. This says classwork on it, but if we have the 3-day weekend, I want you to actually work on it there. Okay? Please work on this.
Yeah, no,
Reading weekend?
Oh, you guys have 3 days till I see you again.
Oh, I'm not doing anything. No, it's not.
Every time you guys have a Friday, you go to work, right? So I don't see you for 3 days, so I wanna make sure that you get more
So
practice.
it's a 2-day weekend, but a 3-day weekend is for classes.
Yes, for your class, sure, absolutely.
I'll make it seem like working hard.
Yeah, yeah.
Are you
We just
gonna-
assuming.
Seeming like I'll
Jordan,
join.
that's that, right?
Can be.
Yeah, yeah, I should be busy.
Because of who's not
I
there.
got most of my stuff done. The only thing I wanted to do tomorrow, guys, one other thing to mention, and I mentioned it in the first period, please don't take this personally, but I'm not recording SATs until people start watching. The first 3 weeks, or the first 2 weeks, 7 people watched the first video, 8 people watched the second video. I can see how many people watch. But the third week, 1 person has viewed it so far. So I have not recorded week 4 yet, and I'm not gonna do it until people start doing their work. So until that changes, I'm not gonna start recording. I appreciate it, and if you really wanna do this and you notice other people aren't doing it, come see me. But I'm not posting a video, I'm handing out the other sheet, I'm not gonna post a video, take one pass it back, until people start watching. Again, there's only 1 video view of week 3, only 1 person did. So I'm not gonna spend an hour recording week 4 when nobody's actually doing the
We
work.
got 2 homework
Okay,
assignments.
until that changes again, people, until that changes, I'm not gonna do this.
Well.
Didn't you hang with you?
Again, 2 worksheets this weekend, 2 worksheets, please. Make sure you get through both of them.